All right. I'm going to start. By writing this part out. Oops. AgCl solid yields an equilibrium Ag plus Cl minus. Okay, can't get any easier than that, right? It's always solid on the left, ions on the right. Solid on the left, ions on the right. Solid on the left, ions on the right. We don't change that. Now, it could be changed for us, and then we'd have 1 over KSP. But for us, we always do solid on the left and ions on the right, yes? Yep. That's the dissociation of any salt. And when there's a double arrow, it means it's insoluble. When there's a single arrow, it means it's completely soluble. And then we just do plain old stoichiometry. But when we have a double arrow, that's why we have to do ice, because we don't have plain old stoichiometry. All right, here's where you got to practice today, the reading. Go back up here. It says, at a cold temperature, 8.9 times 10 to the minus 5 grams of AgCl will what? Dissolve. Didn't they just give me solubility then? Who did? They just gave it to me in grams instead of moles. It says will dissolve in that much water. Okay, so here's the key that I need you to grasp onto today. They gave you the solubility. They just didn't give you X directly. When we're doing KSP in an ice chart, X is the amount that dissolves in moles per liter, yes? And that's why SimGauge made you call it S. So it might stand out as the solubility as opposed to just being X. AP exam usually doesn't do S. They have in the past, but not often. So that's why it's good that we've seen S on the SimGauge for those of us that took the time to do it. All right, so calculating the solubility in moles per liter. Well, I have 8.9 times 10 to the minus 5 grams. If I divide that by the molar mass, and molar mass, I think I got something like 31 or 21, 32, okay, grams per mole. And so that gives me something like 6.21 times 10 to the minus 7 moles. So if I'll now take that and divide that by my 0.1 liter value, which is 100 milliliters, I get 6.21 times 10 to the minus 6 moles per liter. Aha! There's my X. Yes? What X, Ms. Matney? The X in my ice chart. So if I go back up here, Z, 0, 0, minus X, the amount that will dissolve in moles per liter, plus X, X is the amount that will dissolve, but it's also the amount of each of your ions. Yes? Yes. Yes. So here's my ice chart that anytime I'm looking for solubility, as long as it's not with some common ion, Matt, need you with me? Got to stay awake. These are zeros. One of them could be replaced with a 0 if it were a common ion. But there is nothing indicated here. It says in water. So it's not a common ion. Those are both zeros, plus X plus X. So when I get down here to this last question and they say find the KSP, that's an easy peasy question at this point for me, because KSP, the expression is Ag plus times Cl minus is equal to X times X. It's equal to X squared. It's thus equal to 6.21 times 10 to the minus 6 molarity squared. Now, let's do a little bit of mental math here. Let's just pretend they gave this question to you on the multiple choice. You know what I do? I ignore the 0.21. And I just say 6 times 10 to the minus 6 squared. What's 6 squared? 36. So KSP is going to be equal to 36 And what's 10 to the negative 6 times 2? Negative 12. Now when I move my decimal, I get 3.6 times 10 to the minus 11. And when I go and do it in my calculator, I get something very close as the real answer. But look, if I had done that without a calculator, I would have been pretty close to be able to pick from choices as to which choice it was without using a calculator. And y'all can do that kind of math. I can teach you that little bit of mental math. Just ignore that 0.21. And you'll come out with 3.6 times 10 to the minus 11, and the answer is 3.8 times 10 to the minus 11. I can pick which answer out of multiple choice that's going to be. Because they're only going to give me one that's 3 point something times 10 to the minus 11. Okay, everybody turn your paper over. Now it gets harder. That's the easy side. That's the easy side.